All right, so chapter 5, this is properties of geometric figures. And we are, of course, talking about triangles to begin with. Now, if you look carefully at this diagram on the board, okay, this is, what is this here? This is the Lethbridge Viaduct, or more commonly known as the High Level Bridge in Alberta. It's the largest railway structure in Canada with a total length of 1,624 meters and a height of 95.7 meters. The steel trestle was built between 1907 and 1909. So inside here you see that we have lots of triangular shapes. Okay, we have beams with cross beams, and there are a lot of triangles or three-sided closed figures that are made on this diagram. Okay, so what do we need to know about triangles here in this section? Well, let's review a little bit. Working with triangles. What kind of triangle is this that has this type of angle in it right here? That is called a what triangle? Yes?
Right angle.
A right triangle. It's a right triangle. Now this is a right angle. You're right. And the triangle is a right triangle, or you could call it a right triangle, a right angle triangle if you want. A little redundant, but it's a right triangle. So, okay. So when we're dealing with right triangles, there are certain properties that are special to right triangles, and there are properties that are common to all triangles. So for example, the ones that are common to all triangles, can anyone tell me what properties of this triangle is common to all triangles, whether that's a right triangle or not?
You have three sides.
Three sides, thank you.
A,
A, B, and C. There are three sides. And as I mentioned before, the figure is closed. Now what do I mean by closed? This is a figure that has three sides, but that's not a closed figure. That's not a triangle, is it? It has to be closed. We cannot have an open spot there. So this would be a triangle, and because it's three sides and it's closed. Okay. What else about the angles of a triangle? Anybody?
they all have to equal up to 180.
Right. The sum of all of the angles of a triangle have to add up to 180 degrees. Okay. Good. Is there anything else you can think of right now? Anything else you can think of right now? Okay. Those are the two main ones. Okay, let's take a look at the Pythagorean theorem, or Pythagoras' theorem, as you might call it. So the sum of the squares of the sides or the legs of a triangle, if you add up those, it's going to equal the square of the hypotenuse, the third side that is the longest side. So a squared plus b squared equals c squared. That's something, honestly, this is one of the oldest mathematical equations in existence. This was one of the first things that was explored by Pythagoras and his group, and yeah, it's one of the oldest ones that we use. So pretty cool. But remember, the c squared that's all by itself there is always the longest side, and it's also called the what? I think I mentioned it, but what's that side called? The hypotenuse. Okay, very good. All right, moving on. We also need to remember that there are special ratios for angles of a right triangle. And those special ratios are the three primary trigonometric ratios of sine, cosine, and tangent. So if we are looking at any, let's have this in the screen, any of these angles, let's say, for example, angle C right here, okay? Angle C, here's C, and this is the angle C right here. So according to angle C, there is a sine ratio for angle C. And again, this is a bit of review, so I'm not sure how much to go over right now, but this works for right triangles only. Okay, if it's a non-right triangle, it gets a little bit more complicated. But for right triangles, the ratio of the opposite side, so you just draw a line straight through the middle of C. See, that's opposite side, divided by the hypotenuse of the triangle, and that's the one that's opposite the 90 always. So that would be 9.4 divided by A. That is the ratio that will fit with angle C. Okay? Now, you can write an equation like that for sine, cos, and tan for angle C or angle B. We don't normally write sine of angle A, okay, because, again, the hypotenuse and the opposite would technically be equal. So it doesn't work for the 90 degree. It just works for this angle or this angle. Okay? Now, just going back to this one right here, it says, this question says calculate the length of the missing side. So write this down in your notebook. If you don't have this down already, write this triangle down with side length 7.6 here and 9.4 here. And the angles A would be here, I guess this 90 degree, and B and C. So just copy that down in your book. So now we have this copied down in your book. It says calculate the length of the missing side. Okay, here's the missing side. All right. Now, if we take a look at the sine ratio that we just wrote out, we have maybe a bit of an issue here. I can't use the trig functions because here I have A that is unknown and C that is unknown. So I cannot use sine or cos or tan to find A. What can I use to find A here? What properties or what formula, what equation can I use to find out what A is here? What do you say? All right, the first one we take a look at was the Pythagorean theorem. So use the Pythagorean theorem to solve for A. And of course this should be pretty straightforward. A squared, or whatever. I mean, the length of the one side squared plus the length of the other side squared equals the length of the hypotenuse squared. So it doesn't matter what's A, B, and C really. In this case, the A, B, and C are a little bit mixed up, but that doesn't matter. So we're going to do 7.6 squared. And remember that's 7.6 times 7.6. It's got to be squared. Plus 9.4 squared equals A squared. So let's just examine this carefully, because what you have to remember is one important thing, that when you add this up, this is not the answer right here, the sum of this, because this is equal to A squared. So in order to get A by itself, we would have to take the square root, the opposite operation of squaring something. And what you do to one side of the equation, you have to do to the entire other side. That's why we have a square root over here. And so this is what we get A to be equal. Now what you want to do when you determine this is to double check to make sure that it's reasonable, okay? And what I mean by that is this. Does it make sense in looking at this diagram, okay? And this is roughly to scale. This AC side is a little bit smaller than the AB side, which makes sense with these numbers. And then this one has to be the largest side. So again, 12.1 is larger than both 7.6 and 9.4. So far, this looks pretty reasonable. If this was 121, if that's what you ended up getting with your calculator, you'd look at this and say, 121. Well, 121 is really long. Like, I mean, it goes off the screen here. So that does not seem reasonable. You're going to want to say, okay, I think I hit a wrong button or something. So you want to make sure that your answer is reasonable, okay? Any questions so far? Pythagoras theorem, we're good with that? Yeah? Okay. All right, let's do a couple build your skills questions here. So here's the first one. We'll do this one together. Use the Pythagorean theorem to find the missing side length. All right, this is pretty straightforward. So here is one of the sides. Again, the sides are connected to the 90 degree, right? So it's going to be this one squared plus this one squared equals this one squared. So we write that out, 69.3 squared plus 47.6 squared equals y squared. So again, write out your equation. Don't try and take too many shortcuts, okay? Don't just look at the diagram and try and do it all in your calculator. Don't do that. And the reason why is because I don't want you to make any silly mistakes. So the more work that we show, the less chance we'll have of doing something wrong. Okay, so 69.3 squared. Make sure you can do that on your calculator. Make sure that you know where your squared button is. You may have a squared button like I do on my calculator here. Or you may have to take it to the power of 2. Your power button might also be y to the power of x. You got to figure out what your calculator does there, okay? 0.6 squared. Okay, we'll double check that to make sure it lines up. All right. Did you get this for a number? 7,068.25? Okay, I'm zoomed in quite a bit here. All right. All right, so is this my answer? 7,068.25, is that my answer? No. What do I have to do? Thank you very much. You gotta square root that thing right there. Take the square root of both sides, and you're gonna get now y equals, take the square root of the answer. You don't have to type out the answer. You use your answer function on your calculator. 84.07, we can say that's 84. Okay, or you can say 84.1, probably be the best. Make sure you have your units for a complete answer. Okay? Any questions on that?
You want units on it?
Do I want units on it? That's a great question. Yes. It's almost like I just said a few seconds ago. Please make sure you have units on it. Excuse me, sir. Do you want units on it? Like units? Yeah.
You want
I
units.
just said units.
You want the units on it.
Yeah. Put the. Thank you. All right. Wow. Yeah. Okay. So now you're going to have to copy this out into your notes if you do not have this workbook in front of you. So there's B. Please take 10 seconds. Jot that down in your book. Leave some space, and I'll show you C. As we continue on to the lesson here, let's take a look at example 2. So example 2 asks us again to calculate the missing side length. So please copy these triangles into your notebook. Please copy these triangles into your notebook. And we're going to calculate the side length W, but notice that we are not given two sides of the right triangle. So we're going to have to use the trig ratios, trigonometric ratios. Okay? So copy down A and B into your notebook, and then let's work on solving for W together. And I'll show you how to approach this. All right. So for example 2 here, you've got this one copied down. We're asking you to find side W, but we aren't given two of the three sides, so we can't use Pythagoras here. All right? 4.2 squared plus what squared equals what squared? That doesn't work. We can only have one unknown. So this is where we look to our trig functions. So remember, so, ka, toa. How many of you remember that little memory trick there? Okay? So means the sine of an angle, whatever it is. We'll say theta, that's a good representation for an angle. That's the symbol that usually is used. Is the opposite side length divided by hypotenuse. And of course for cosine is A over H, that is the adjacent side to the angle divided by the hypotenuse. And for tangent of any angle, you use the opposite side length divided by the adjacent. So how's that going to help us? Well, we're given an angle, and I'm given this side. So according to this angle, what side is 4.2? Is it the opposite side, the adjacent side, or the hypotenuse? Yeah, it is. It's the adjacent side. Good. This is the opposite side over here, and this is always the hypotenuse. So, how do we write an equation where we're only missing one piece of it? Well, if I use the 41 degrees, if I use the adjacent side length, I can then solve for the hypotenuse. So which trig function uses the adjacent and the hypotenuse? Let's see, right here. You see that? Adjacent and hypotenuse. So I'm going to use this. I'm going to use cosine of 41 degrees equals what? What's the adjacent side to 41? It's 4.2 equals 4.2 divided by the hypotenuse is W. So that's how you set that up. And you want to write out that equation first, and then you can solve for W. So you guys know that if we have a simple ratio, we can multiply both sides by W. That brings it up here, right, as a multiplier there. And then we can divide by cos of 41, and so that brings it down here. And so what we have then is I'll change my color here. we have W equals 4.2 divided by cos of 41 degrees. Right? So, on your calculator, it should be pretty easy. You simply do 4.2 divided by, where's your cosine button? Right here. And type in 41 degrees. 5.565 or 5.6. Okay, and that would be in meters. So let's see if that's reasonable. This is 4 and this is 5.6. Yep, it's bigger than this one. If this is drawn to scale, which may or may not be, that's pretty reasonable to think that that might be the answer. Okay? All right? Okay. So another one that we want to do here, another type of question, this is one more that we'll do here before you can copy down some practice problems of your own. But let's take a look at one where we're trying to find the angle measure. And I'm not sure how much you remember of this type of question, but let's give it a go. So this one says, calculate the measure of angle E. Ooh. Well, first of all, we have a right triangle. Here's the right angle right here. And we have two sides, and we're trying to find this angle. So again, two sides of a right triangle and an angle, we're going to use our trig functions. Which trig functions can I use to solve for E? That means which trig function involves this value and this value. Any guesses? Sine? Okay. Let's check that out. This 2.8 length is the what side compared to E? Is it opposite, adjacent, or hypotenuse? It's the opposite. Very good. This side compared to E is what? Well, that is opposite the 90, so that is always the hypotenuse. Good. And so O and H, that is so. So you were absolutely correct there to say sine of the angle, I don't know what the angle is, so I'll just write E, equals the opposite side length over the hypotenuse. Okay? Again, so just write the equation that you can. Make sure there's only one missing part. If you have two missing parts in the equation, can't solve for two at a time. You can only solve for one of them at a time. So, boy, I don't know. Does anyone remember how you solve now for the missing angle in there? Like, how do you get E by itself? You remember how to do that? Okay. So, if you look on your calculator here, there is the sine function, but look at right above the sine function. That is sine to the negative 1. Now, that's the inverse sine. And that's how we can peel off this sine from the E. Because they're pretty tight together. Okay? You can't just divide a sine off. You have to somehow isolate E. And how you do that is you take the sine to the negative 1 of both sides. Okay? And that means that we have this. E equals the inverse of sine, the inverse sine of 2.8 divided by 3.9. So, how do we do that in our calculator? Pretty easy. You do second function sine, and you might have to type in the numbers first. Okay? You guys pay attention? Okay? Do this on your calculator, make sure you can do it. Your calculator may be a little different than mine. So 2.8 divided by 3.9. And let's see what that gives us. 45.885 or 45.9. Does that make sense here? Let's see. Well, that, if this is drawn to scale, that could be pretty close, so that's reasonable. So 5.9 degrees. Make sure you use your units there of degrees. And that appears to be our solution. Now, I do have in the workbook here, I have the solution for B. Let's see. Oh, there we go. So they've rounded to the nearest degree, which is great. You can be fairly exact and write your one decimal place. I'm good with that too. Okay?
I got 48.
You got what, sorry?
48.
You got 48. Okay, I don't think you should have gotten 48. Can you try that again? And can you please make sure your calculator is in degrees? You should have a little D on your screen, or if it's an R, that's no good. If it's a GRAD, that's no good. Try that again. Let me know what you get. Please take a moment to copy down these three triangles, and in this, you're to solve for x. Okay? Then we'll do number 3 next, and we're solving for a. All right. So here's letter C as well, and again, get you to copy that down if you haven't done that quite yet. Given 2 sides, solving for a, and then we're going to work. We're going to do one more little piece to this lesson before we round it out for today. So let's work with properties of triangles. Now, we've already talked about this already, but here's where they formalize this sort of stuff that we've already talked about. So let's go over this fairly quickly. Guys, listen. You ready? Okay, a property is a characteristic that classifies the object and distinguishes it among other types, objects of its type. So the properties of a triangle. Well, we've done a pretty good job of stating these already. It has 3 sides and is a closed figure. The sum of the interior angles is 180 degrees. So we talked about this earlier. Now is a good time to jot these down as notes, properties of triangles. Okay? So a triangle is a closed figure that has 3 sides only. And the sum of the interior angles, or the sum of all of the angles inside, that's what interior means, they have to add up to 180, no exceptions. Question?
I'm saying, I was going to ask, like, can there be a triangle?
All right, yes, every triangle, the angles add up to 180 degrees. And maybe if we have time at the end of the lesson, I'll maybe demonstrate that for you. Okay? Yeah. All right, so triangles can be classified. There are 3 types of triangles. They can be classified with the by their angle measure, so that's what we'll focus on first. So let's use red. An acute triangle. What is an acute triangle? Well, it's a tiny little cute triangle. Think about it that way. What's tiny about it? Each angle is tiny. Each angle is less than 90 degrees. That's what an acute triangle is. Let me zoom in for you so you can copy that down. All 3 angles measure less than 90, and that's a sketch of an acute triangle. That's acute.
Wait, can I write equal to Q?
Okay, the right triangle is next. It has 1 angle that is 90 degrees. You cannot have a triangle that has 2 90-degree angles. I'll try and draw one here for you. 2 90-degree angles. If they're both 90 degrees here, any 2 angles, then these lines are parallel. Therefore, by definition, they will never intersect. So we can never have a closed figure. Does that make sense? If one of these angles is less than 90, oh wow, that was weird. If one of these angles is 90, but the other one is only 1 degree less, then what happens is they will intersect, but it'll just happen to be at some point in the far, far distance. Okay? So this could be 89 degrees and this could be 90, and that's okay. It'll just be a really long, pointy triangle. Now, you could probably see, and this leads into the next one, but we could not have a triangle that has a 90 degree and another angle that's greater than 90 degrees. You see that? If this was, let's say, 101, then it'll never be a closed figure. They're diverging away from each other. They will never meet. So that leads us to obtuse. An obtuse triangle has 1 angle measure greater than 90, and that's possible, as is shown in this sketch right here. So if an obtuse triangle must have 1 angle that's greater than 90 and 2 angles that are what? How would you describe those 2 angles? They are little or acute. Yes, they are acute angles. They're tiny little cute angles. Aw, isn't that angle so acute?
No.
So these are classifications according to angle. Guess what? There are also classifications according to, let's see here. According to side length. All right, so let me make this diagram a little bit bigger for you. Come on now, let's stretch that out here a bit. Okay, whoa. Can you guys see that all right? Ish. Okay, so this one right here, this chart shows you how we can classify angles according to side length. And if we have a triangle where all of the sides are the exact same length, then it's called an equilateral. Equilateral. And that shouldn't be too hard to remember because equal, you see, you almost have the exact word equal. And lateral means kind of like the sides. Lateral. So equal sides. That's equilateral. The next type of triangle after equilateral is isosceles. Now this is probably the strangest word in trigonometry, even though trigonometry is pretty strange, I gotta admit. But isosceles, tough to spell, not too tough to say, I guess. But it's a triangle where two sides are the same. Two sides are equal length. So this one has three sides equal length. This one has only two sides equal length. Now, what's neat about this, and I will go back and highlight this now, an equilateral triangle not only has three sides that are equal, it also means that all three angles are the same. So if we have three angles that have to add up to 180, what is the size of each angle? All the angles are equal. So what plus itself again, or what is 180 exactly divided by 3? Anybody?
60.
60, yes. So each angle is 60 degrees. Now, when isosceles, you can't really tell what size these angles are. Why is that? Well, because they could be super small, like this one right here, say pretty small, even though these sides are the same, or they could be pretty large. If we had a tall, skinny triangle, kind of like this, each of these angles are pretty big, and that would still be an isosceles triangle, you see? So you can't really tell what size they're just by calculation. You'd have to know some other information, but that's an isosceles triangle. Okay, the final one here is scalene. Isosceles and scalene. These are really strange words, aren't they? You can look up the origin of these words later as a side project if you want. All sides are of different lengths, and none of the angles are of equal measure. So one of the ways you can show this in a diagram is by making each side have different little tick marks on them, and so that means that they're all different. See, the smallest one might have a 1 tick mark, the second biggest one have 2, the largest have 3. But it doesn't really matter. As long as you have different numbers of little tick marks, that shows that the sides are different. And even a right triangle can be scalene, right? That's pretty easy to understand. Okay. So any questions about these 6 classifications of triangles or the 3 main properties that we talked about? All right. Okay. So let's round off our lesson by doing, let's do this example right here, okay? Actually, you know what? Just for your sake, for time's sake, let's actually skip to the build your skills, and I'll let you copy these questions down here. Give me 1 second. I'll zoom this out for you. Okay. Build your skills. So number 4, so copy this question down, number 4. Take a moment to do that. Okay, so here's a triangle. What is the measure of angle M? Okay, so we have to put our thinking caps on here. So first of all, we have to understand what kind of triangle this is. What kind of triangle is this? Looking at the chart or the information that we just learned about, what kind of triangle is it? Anybody?
Isosceles.
Isosceles. Yes, it is. It's isosceles. Why is it isosceles? Sorry, I wasn't making fun of you. I was just imitating you. That's the highest form of flattery, really. Imitation. And I know you meant to, okay, say it like that. Okay, good. As long as we understand each other. So look at this. These two sides are exactly the same. So this is not what the question asks. However, do you know what the side length is? MN? Yes, you do.
Yes, we do.
It's 15 meters. Because it's the same as this one. Now, by looking at this, we're asked about M, but what's an easier angle to identify here? Is it easier to identify angle M or angle P given this diagram? Which one is it? Is it easier to, well, when somebody said M, somebody said P. Which one is easier knowing this is an isosceles triangle? Okay. An isosceles triangle, okay, watch this. The easiest one to spot here is angle P because it's the same as angle N. That's 60, right? Right, because this is 60. Now, if you said angle M, why did you say angle M? Don't know?
Who said M?
Somebody said M. It doesn't matter. Okay. So, this, now look at, what do you learn here by writing this 60 down right here? What do you know? What do you notice? What do you notice? What other kind of triangle is this now? We realize. Anybody?
Acute.
Yes, it's an acute triangle. Yes, that's not what I'm going for though. It's isosceles, but it's also what? Knowing that these two angles are 60, okay, what does this angle have to be then?
Oh, 60.
Yeah, it has to be 60. That's very good. So what's the angle, angle M, measure of angle M? 60 degrees. So what jumps out at you now? What type of triangle is this now? What's another name for this?
Equilateral.
Yes, very good. Because look at, they're all 60. So this side has to be 15 meters as well. Okay, great. So we can answer letter B now. Classify. Oh, do you guys know what this means here? This little, this notation right here? That means triangle MNP, and that's how you can name a triangle. M, you just list the corners or the vertices of the triangle. So this is triangle MNP. Okay? Okay. So classify M and P by angle measure and by side length. So we've already said it. It's an equilateral triangle. And is that because of the angles or because of the side length? Equilateral. That's because of the side lengths, right? And the only reason why I say that is because, remember, equilateral. That's the equal sides. Okay? And what's another way, and somebody mentioned this already, what's another way we can classify this according to angle measure? It's a what kind of triangle? Yeah, it's an acute. Awesome. It's an acute. Okay? Is it a right triangle?
No.
No. Is it an obtuse triangle?
No.
No, because it doesn't have an angle that's greater than 90. So it's equilateral, it's acute. Technically, is it isosceles?
Yeah.
Does it have two equal sides?
It's a
Technically, it's isosceles too, I guess. Let's go back and see here. Let's examine the definition if we're not sure. Where is that definition? Okay, isosceles. Two sides are of equal length, and two angles are of equal measure. Boom, that actually, technically that qualifies as well. So, awesome. So an equilateral triangle is also an isosceles, but not every isosceles is equilateral. That's deep. That's deep right there. Okay, so have you copied number 5 yet? I didn't let you. Well, I'm letting you now. Go ahead. There's number 5. Do number 5. And then after that, you'll do number, guess what comes after 5?
7.
7, correct. Oh, wait.
8, Chris. Oh, yeah.
Wait, no, it's 8. No, there's number 6 as well you can do. So happy trigging.